Um, Hello everyone. So welcome to today's DSA Code Along with FAAMG SDE. Today here I have with me Athreya, who's been my friend, and he's also. I'll let him introduce himself. But if I have to introduce him, I'll say he's one of the smartest coders I know. He's the most knowledgeable person I know, and he's also extremely humble. So throughout this live stream, please feel free to ask any questions you have regarding placements or how to even get better at DSA to Athreya, and he'll answer them. So what do you, Athreya?
Hi everyone, I'm Athreya. I'm currently working as a software engineer at Microsoft and I take care of SharePoint iOS. In today's stream, we'll try to solve a bunch of problems that will help you in placement preparation. And like Vasu mentioned, feel free to ask any question in the chat as well. So let's get started. The first problem we'll look at today is the kth largest element in an array. And let's look at what this problem is. We're given an array here, and let's give an example. And let's say the array that were given to us are 3, 2, 1, 5, 6, 4, right? And now we're given a k value. Let's say k is equal to 2. We're supposed to find out the second largest element here. So what does that mean? In this array, the first largest element would be 6 and the second largest element would be 5. So 5 should be the output. One simple approach that we can think of is, why don't we just sort the whole array? And after sorting the array, go from reverse, and 6 is the first largest and 5 is the second largest. Because k is 2, we went 2 positions from the back in order to get the kth largest element. The time complexity of this approach would be n log n, where n is the size of the array. But can we do something better, or can we try to use another data structure for this purpose? One thing we can look at is heaps, and there are two kinds of heaps basically. So there is a min heap, and there is a max heap. And these heaps are internally stored in memory as trees, but we don't need to go into the implementation internally. But we need to know that when these are stored internally in memory, the property that is maintained is that the root of this max heap will always contain the maximum element. And then the root of the min heap will contain the minimum element. The root of the max heap basically will contain the maximum element. So max contains max and min contains min in the root. The property that's maintained is that these heaps have log n for insertion and log n for deletion because of the balance tree property that they maintain. So let's look at this approach and how to kind of code this out. This, yeah. So looking at it again, let's look at the max heap approach here. If you want to use the max heap approach, it's really simple. If this is the array given to us, we put all these elements into a max heap. So let's say we have a max heap right now that consists of all the elements here. The property that I mentioned, in the root, you would have the maximum element of the whole array here. So after inserting all of these elements, the root here would contain 6, the maximum of all the elements here. Now, since k equal to 2, it means that we want the second maximum element present in our arrays. The first maximum is 6, the second maximum is 5. So what we do is, as many times as k is there here, we try to delete elements. So first, we would delete the root here. Once we delete this root here, the first largest element is out of the array, and the heap restructures itself in order to get the next maximum here. The next maximum is 5 basically. Because k is 2 and a deleted 1, what's the root of the tree now is the second maximum. This is the max heap approach. And because there are n elements here, right? First, what did we do? We put all the elements into the heap. So that itself takes n log n complexity. And then we're kind of doing an upper bound of k deletions in order to get the, kth largest element. So it's n log n plus k log n basically, but again, upper bounds to n log n itself. So this is one approach. The other approach is slightly counterintuitive, where we try to use a min heap. So you might think about, why do we kind of use a min heap even though the question asked for largest? So the approach here is, let's see what to do here. So let's again have the same array 3, 2, 1, 5, 6, 4. Here, um, the main criteria is we want to maintain the heap size of k elements only. So that means that first, what would we do? We'll insert 3 into a heap basically. There's a min heap that we're trying to maintain. We insert 3, then we insert 2, then we insert 1. Once we insert, let's say that you want to find out, in this case, the third largest element. Right? Let's take a slightly different case, because first largest is 6, second largest is 5, and the third largest is 4. So the output that you want is 4. And first you insert 3, insert 2, insert 1. And when you insert 5, right, the criteria changes in the sense that you have more than k elements in your min heap. So more than k elements were present in your min heap. And so at this point you can delete. And what will you delete? So after inserting these elements 3, 2, 1, 5, the root of the min heap basically contains a minimum element so far, which is 1. Right? And then you have the remaining 3 elements there. You delete this. So this is the element that you currently deleted. And now your heap size is back to being k. Then you insert the next element 6. After inserting the next element 6, the root Like basically after deleting one, the root changed to being the next minimum, which is 2 in this case. And now after inserting 6, the root does not change because the minimum still remains 2. You can delete this out. And now again the heap size, if you look at it, right? You deleted 2, it's now again the heap size is set to be k. Now you look at 4 here and you try to insert again, like before you insert it, the heap will internally restructure itself and it would have 3 here basically. And now if you look at it, right? When you insert 4 into the min heap here, again the property is violated. You have 4 elements in your min heap while you're trying to maintain a k size heap. So again you would try to delete the element at the root of your min heap, which is the minimum element. You would delete this. The heap would kind of restructure itself and the heap would contain 4, which is nothing but the minimum element after deleting everything. So one intuition of trying to understand of why does this work is basically, if you think about it, right? If you try to sort everything like this 1, 2, 3, 4, 5, and 6, and let's say k is equal to 3, looking at it, simple to know that 4 is the third largest element from the back. But how many deletion did you have to do from minimum elements? You had to, let's say this is k. And for example, let's just number the indices 0, 1, 2, 3, 4, and 5. These are the indices present, and you want the kth largest. So in other words, the size of the array is 6, and you want essentially the n minus kth element. This is what you want. If the size of the array is 5, I mean size of the array is 6, and then you want the third largest element, this position, right, is basically n minus k and n minus k plus 1 based on whether you have like, 0 indexing or 1 indexing. But the main thing what you have to kind of note here is you had to do 3 deletions from the minimum. So k is basically, because it's 3 here, 6 n minus k plus 1 because 0 indexing. But you had to do 3 deletions from your min heap in order to reach this. So that's the kind of the intuition behind this approach. And we'll try coding both the approaches and you can use like whichever is better here. But the complexity of this min heap kind of approach is, since you maintain the heap size to be always of size k, and you're doing the insertions of n elements, it's more like n log k in that case, because you're inserting elements n times, but log k will be the factor because the heap size either k or k plus 1 in every case. So we'll try coding it out. Give me 1 second. Yeah. In C++, you kind of use a priority queue here to kind of simulate min and max heap. And let's first use the simple approach of using a max heap itself. And so this is kind of in C++ default is max heap. Then we run through every single element there. And then all we do is, let's take the element. So let's say it's index. So this is the max heap approach where we insert all the elements into the max heap first and then try to do k deletions in order to get to the kth largest. This is the more straightforward approach. We push everything into our, max heap, and then let's have an element to keep track of the pop element. So now all the elements are within our max heap. And initially the max heap will contain the largest element. We have to delete k times in order to reach to that. So all we do is we look at the element that is currently on the top of our max heap, and then we pop that element out. And then at the end, this variable will contain what is required for us. Let's have this. So this is what the approach is using the max heap. I'll just test it out. So yeah, so it does work in this case. Let's quickly look at the approach using min heaps as well. So in order to use min heaps, at least in C++, you have to have a comparator because the default is max heap. So convert this max heap into min heap. We need to kind of pass a comparator at the end, and we can do that by using the greater comparator. So we have a built-in kind of comparator that reverses the order of comparison. So this is now a min heap for us. So again, we do kind of a similar approach, but instead of doing all this, we'll change the code. We process element by element and we push it into our min heap. At any point, if the size of our heap, right, if the size of our min heap exceeds the property that we're trying to maintain, we try to maintain a k size heap. So if the size is greater than k, we can directly go ahead and pop it. And we are guaranteed that the element that we pop from this min heap is never part of our answer. Because if you look at it, if you have an array that you want the kth largest element, you need to pop a certain number of minimum elements from the start to reach that kth largest element as well. So you can pop it directly, and at the end, you can try returning what is on the top of the heap. So let's try this out. So, yeah, so this is kind of the approach. And here we look at it, we're running through every element of the array and we're pushing the element. But since we're maintaining the property that the size never exceeds k, the factor of insertion deletion is just log k in that case, which is why this kind of works in this way. And I'll hand over to
Yeah,
Vaishnav for the next
so
one.
perfect. So I feel that was very, very instructional. But one thing that I want to ask you, and a lot of people ask me as well when they're in college, is when you start out with the preparation for interviews, or you're just getting started with programming preparation, how do you go about it? If you were in first year, what would you do now?
I would say uh, I would choose a language. I would decide like whether I would suggest one of the three things: C++, Java, or Python, and then select a language. Get familiar with the language constructs. In Java, you have collections. In C++, you have STL, and Python, you have collections again. So look at the language. Like main things like you need to know priority queues or heaps, how are they implemented, how to kind of use that, custom comparators, sorting functions, basic things about other yes, language specifics as well. So make sure that you know your language completely, at least to the extent where if you're given a problem that just requires you to translate a given problem into code, you can do that directly without any logic or anything. Let's just say you have an array, you want to reverse an array, let's say. You need to be able to understand loops, you need to understand the language specifics. And then once you understand as a linked list, you need to know how to define a linked list and stuff. Once you do that, I would suggest you to start like solving, let's say, if your goals for placements, like get started with geeks for lead code and then start with a few easy problems. But once you're comfortable enough with, let's say, 10, 20 easy problems, stop easy and go for medium problems. Because ideally in an interview, you would most likely only have medium and hard problems there, mostly medium, some hard as well. So easy problems are more like warm-up problems, so pretty much they're not non-existent there. So just start with medium problems. Look at Blind 75, other lists that are very popular. You can just Google and find like millions of lists. Choose the list that is comfortable for you and start solving. Like let's say arrays, start with arrays and strings, go for linked list, then go for recursion DP, and then go ahead with that.
Perfect. So you really think that if I'm a first year student or somebody is, they really have to design a language at the start?
Right. I think it makes more sense because I see some people they because of their college structure they
Mhm.
kind of let's say they choose Java, let's say college is there in OOPS and Java and stuff. Then at the end of the day they realize that you know what, during placement time C++ they will learn Python and they have to kind of unlearn what they had in Java and then again learn the collections and everything else in the other language. Rather than I would think it'll save more time if you decide on the language at the starting itself and stick to that.
Perfect. And any language suggestions that you have for somebody starting out now?
I think any one of the three languages, C++, Java, and Python are pretty much, I think.
Perfect. So yeah, hopefully I think that's a great answer. I think a lot of people ask me to, and probably a lot more people ask you what language that they have to start with. And yeah, so even I felt the same when I started learning coding, and I think there was a plateau which I hit very, very quickly. But then I coded in Java for a very long time. But when I started learning things like hash maps and other data structures, as you said, I felt like it really opened up coding to me and the type of problems I could solve. So yeah, so without further ado, let's just go to the next problem, which I'll be explaining. So this is another famous problem. So how often do you think a problem like this comes up in an interview?
I think this type of problem, or at least the approach that is solved, is very famous in metaphysics.
Got it. So this is the problem that we're going to be looking at. And quickly, I'll just change my language to Python 3 and hopefully also just increase the font size. Okay. So let us read the problem again. And as I said in the previous sessions, my approach is always a bit different, where I try reading I mean, maybe I'm not as well versed as Athreya here is, but my approach is very simple. Read the question. If you don't understand, read the inputs and outputs and then, if you're not able to do that, and sometimes constraints are also a very good clue as to how to solve it. And that isn't advisable, right? If you're like,
I think it makes sense to kind of clarify with the interviewer. Sometimes they do give you the constraints, and it's also a good indication that, let's say brute force won't work and you can.
yeah. Okay, so let us quickly look at the problem and try figuring out what it's asking us to do. So, given an integer array nums, find the subarray with the largest sum and return its sum, right? So, basically, again, I think this is one of those problems which is very simple to understand. We have this huge array of numbers, and we just have to give that sub-array which is present inside this array, which results in the highest sum, right? So I mean, the basic intuition is if you just had like all positive numbers or just all whole numbers greater than zero, the sum of the whole array would be the maximum sum sub-array. But here in this case, we also have negative numbers, and that gives us a new challenge, right? How do you navigate this sort of sub-array with where you have negative numbers? So let's just look at the problem and try to understand what we essentially should do right here. So first we have minus 2, and then 1, minus 3, 4, minus 1, 2, 1, minus 5, and 4, right? One basic intuition here is if I have like a negative number, right? And probably it's not going to contribute a lot to my maximum sum, right? So if I have a sum and I'm adding something negative to it, and there's no way that after adding something negative to that sum that I already have, it's going to become the maximum. So this is going to be our strategy. So, okay, I'll just put it in a different way. Let's say you have five friends, right? And let's say three of them and you're going for a let's say a party, right? And so ideally you want guys who can pay money and like get you a good treat, right? So that's one way to think about it. So let's say if all five of your friends had like a good amount of money, and you and it's fine, you can take all of them and go to the party, right? But there may also be a case where some of your friends don't have that much money. Let's say two of your friends don't have money, but the other three have a lot of money to make up for it. So that is also a case where you can take them to the party. And this is simply because the three friends who have money, in cumulative, they have more money than the two guys that don't. So that is our basic intuition, right? If the cumulative total of these guys is less than zero, you don't want them at the party because they are a net negative. So that's some approach that we'll be solving. And the algorithm that we're going to use here is called Cadence algorithm. It's a very, very popular algorithm. You can go check it out. But I'll just start coding it and maybe we'll get better intuition of the problem. So let me just initialize current sum to 0. And one of the constraints in this problem says that um, find the subarray with the largest sum. Okay, fine. So what happens if our subarray only had negative numbers, right? So usually sometimes the first mistake that we would do something here is first we would initialize max sum to 0, right? But if our array had only negative sums, then probably uh, the value 0 that we have assigned to maximum will never get changed, or whatever algorithm that we employ in the middle. So again, here's a trick. Just when we start understanding the question, we realize that okay, there's a situation where there's only negative numbers. So one good strat to do here is just assign the first index element as the max sum, right? So now we're going to do something very simple for val in nums, right? So let me just look at first, the current sum up to the first element is minus 2 here, right? So what I do is I just add it here. Current sum is equal to plus equal to val, right? So whatever value that I'm looking at in the array, I just add it to my current sum, right? And now I check if max sum, I simply say my current maximum sum will be the max of my current sum and what I already had in the max sum. So again, that's kind of self-explanatory. And now here is where the logic I was telling comes into play, right? Now let's say I'm going first I go to this element 2 and I have minus 2 in my current sum, right? And in maximum I had minus 2, and once I finish this part, I again say maximum in cursor, which will again end up with minus 2, right? So I had like minus 2 in maximum and minus 2 in cursor, right? I'll end up. But now when I try accumulating this sum into the next element, right? So when I try saying minus 2 plus the next element, now is this current sum which is negative, is it going to result in a greater sum than what is there in the next value? For example, if I add minus 2 to 1, it's going to decrease the value of what 1 had. So it's going to result in minus 1, which is obviously lesser than 1. So whenever we have a negative sum in our current sum, what we simply do is just say current sum is equal to 0 if current sum is less than 0, else current sum. So this is very simple, right? If my current sum of all these elements that I've looked at so far, if it is greater than 0, that means they're going to add value to me in the future, right? So that time I keep it. If it is, however, negative, I know it's going to end up decreasing my sum when I include the next number, so I set it to 0. Now, once we have done all this, our solution becomes very simple. We just go and return the maximum sum. So let's just run it. Yeah. So let's just submit it also. Yeah. So this is Cadence algorithm, and there's a much simpler way to do this same approach just by using the array elements itself. Um, but I want to ask you here, Ajay. I've always been reading about problems like dynamic programming, two sliding windows, and two pointers. So, what was your approach to like learning all these algorithms?
I would say usually, at least for dynamic programming, I started with the recursion path of just finding the recurrence relation and then doing it. Then for these kind of problems, this is of course you don't have any additional space. You do have variables, but you don't have any additional space like except the input, right? So this is kind of the most optimal way to do it. But when I started out, I kind of made myself to have like a 1D or 2D DP array and kind of define a DP recurrence. So when I started this problem, for example, my DP occurrence was the maximum subarray sum that can be obtained at a particular index. Have like a DP array there, and then find the DP difference, like using the previous index and the current index DP corrections, and then do that. Even though it's not the most optimal one, that's why I kind of started it out to just make sure that I kind of get it through the complexity. And then after that point, I think just practice, so just the famous ones, right? Cadence, and then LIS, LCS, and those things, and then eventually got like to that level where you can do your own ones.
Okay, and this question I read somewhere, and I want to ask you, what is your favorite algorithm?
Uh, I think I I think the algorithm for two things. I think for longest increasing subsequence, I do like the DP recurrence for that, and I would say for finding if a number is like a power of two, I would say that that's the O of one approach of just using bitwise and there as opposed to the
Wow. Yeah, great. So I think now we can move on to the next question, which you'll be taking over again.
So let's go to the next question. The next question is called binary tree right side view. And here it's given the root of a binary tree. We have to, return the right side view of it. Here, if you look at the tree, it has 1, 2, 3, 5, and 4. And the right side view is essentially the nodes 1, 3, and 4. So let's look at the input and output. If you look at it, right, the output is 1, 3, and 4, which is nothing but if you look at the tree from the right side, what are the nodes that are visible? Let's kind of look at it in from this perspective as well. Let's say we have a tree, and let's say this is one, this is two, this is three. Let's say you have four here. Let's say this is the case, right? If you look at it from the right side, so what exactly happens? You see node 1, you see node 3, and you see node 4. So these kind of are part of your output. So 1, 3, 4 essentially are part of your output because these are the nodes that you can see while looking at the tree from the right side. Taking another case, right? Let's just say you have a skewed binary tree. Let's say this is your case. If you look at this tree from the right side, 1, 2, and 3 are supposed to be your output. And let's take one last example. Let's say you have 1, 2, 3. Let's say you have 4, 5, and let's say you have 6 and 7. Let's say this is the case that you're trying to look at. If you look at this binary from the right side, 1, 3, and 7 have to be your output because these are the nodes that are visible if you look at the tree from the right side. And when 1, 2, 3, 1, 2, 3 is kind of the output. So, what is the approach that we can think of? So, the approach that I can think of is why don't we just do the normal breadth first search and always store in your answer the last node in every level. For example, this is level 0, right? And this is the last node of this level. This is level 1. There are two nodes, but the last node is essentially node 3. Now, these four nodes, 4, 5, 6, 7, are part of the next level, but the last node in that level is node 7. So, all we have to do is keep track of the last node of every level using breadth first search, and that's more than enough. So, let's just look at BFS once and kind of explore it. So, just a quick overview of BFS is let's just say this is what we have. Let's take a normal like full binary tree. Initially, we'll have a queue structure, and we will have the starting node. So this queue would contain the node 1. Then what would we do? We would see how many nodes are there in this queue. We would find out the size of this queue. In this case, the size is 1. There's only one node in our queue right now. Then we would run a for loop for size number of iterations, and we would pop out this element from the front of the queue, and then we would check if this element has a left and right node. In this case, this element does have a left and right node, so 2 and 3 would be pushed, corresponding to the left and right nodes of the node 1. So what essentially did we do? we kind of processed one entire level here. And because this node 1 is the last node of its particular level, we would also have a answer list, and we would add one node here, this node here. Proceeding here, the size gets updated to 2 here because now you have two elements in your queue, which also indicates the number of nodes in your current level. That's what this size variable kind of answers, to make sure that the only reason you kind of need this variable is you want to process exactly the number of nodes of this level. While processing 2, you end up adding 4 and 5, and the size changes. So that's why you kind of pre-compute the size earlier, and you want to only process two nodes here of this level. So because the size is 2, you would initially process the node 2, and then you would check, does my node 2 have a left and right child? It does. In this case, it does have it. So I add my 4 and 5 at the end of the queue. And then again, the size is 2, so two iterations. One iteration is processed. The next iteration, I pop 3, and I check. Does my 3 node have a left and right child? It does have a left and right child. So 6 and 7 are added after 4 and 5. So my queue has 4, 5, 6, 7 right now. And if you look at it, when I process this node 3, right, it is basically the last iteration of its particular level. So again, in my answer, I would add 3 because it's the last node of its particular level. Now my size would get updated to 4. And why would it be 4? Because there are 4 nodes I need to process in my last level here. Because it's 4 here, I will initially pop out 4. 4 has no left and right child, nothing would be inserted to the queue. Initially, it'll go to 5, it'll pop out 6, and then last again when I pop out 7, I know this is the last node of its level, and 7 would be here. If you think about the time complexity of this kind of BFS approach, it's just nothing but the number of nodes in the whole tree, because that's what I'm doing, processing every node in the whole tree. So let's look at the code here. Okay. So I have one corner case that says that if my root is already equal to null, then I just kind of return an empty array there. And otherwise, I have my queue, and then I will push my root as the first element of my queue. While my queue is not empty, I would iterate. And like I mentioned, I would find the size. So size is now q.size. And then I would run a for loop for that many number of iterations. So this size number of iterations essentially denotes there are these many nodes in this level to process. So that's what it kind of indicates. And now I also need to have a vector answer because they want the right side view, which is nothing but the values on the right side. So I have my vector answer. And let's go ahead. So I basically need to process these many nodes in the current level. Initially, I only have one element, which is nothing but the root that I pushed. So that's how I start. This is the current node that is on the front of my queue. Now I pop this and then I check. Does my current node that I'm popping from my queue, does it have a left node? If it has a left node, I will push that into my queue. Now I will check, does it have a right node? In that case, I will push it to my queue. Now next, I need to, this is the property that the answer requires. It is, I need to find out the last node of this level. This is why the for loop comes in handy here. If I directly check, right, if my j is equal to size minus 1, it means that I'm currently at the last node of particular level. If you look at it, when I'm crossing the level, if you start a level from 0, the root is at node 1, level 1 has a nodes 2 and 3 in this example here on the left side, and level 2 has 5 and 4. So essentially, if my j is equal to size minus 1, I am at the last node of this particular level. So then I would kind of directly do answer.pushback, the value corresponding to that node, which is nothing but current value. Mhm.
I think Canada is covering the
Oh, okay.
code, so we just move it a bit.
Yeah,
Thank you so much for that, Aaron. I really appreciate it.
thanks. So is this fine now?
Yeah, I guess so. Yeah.
Okay, yeah. So basically what we need to do is we need to find out the last node of this level. And so if j equal to size minus 1, I'm at the last node of this particular level. I can directly push the value associated with that. Then all I have to do now, because my array has already been built, my answer array, I can return the answer array directly. So let's just run it and check. Okay, so there is, okay, I just missed out a semicolon there. be fine. Okay, so okay, this is current, and it's finished like that, and this also should be current. I think that should be fine. Yep. Think yeah, this should be fine. Yeah, so I just submitted. And if we got accepted, and if you look at the time complexity for this, even though we kind of seem like having two nested loops, like we have a while loop and then we have another for loop inside, essentially this is nothing but, if you think about it, how many nodes are you popping in the worst case? How many times does this line get executed on line 28? All that's happening is you're going to pop as many nodes as there are total number of nodes in the tree. So if there are n number of nodes in the tree, you would not pop more than n nodes. So despite having two nested loops, this is not n square, it is still O of n here in this approach. And yeah, so that's the code here, and I'll hand it over to Vaishnav.
Yeah. So one of the questions that I also get is people find like I think there's this understanding that if you want to crack harder companies, you have to know graphs and trees. So what is the path like that? Uh, are you good with arrays and strings? Some people find graphs really hard.
Yeah, I would say initially when you start out, it seems like graphs, let's say, or DP and recursion, these are much harder than general problems. But I would suggest that if you just solve certain problems like number of islands or some certain BFS problems, top view, light view, some stuff like this, you will get comfortable enough to use BFS or DFS in any of your normal problems. So some people are more comfortable with DFS and recursion. Some people, for example, in my case, I'm more comfortable with using BFS for this. So if you know a particular approach, stick to that and then just know how to do both of them, of course. But don't have the mindset that it's too hard and I'm not going to try it. Because a lot of people I know, they just look at problems on trees or graphs and they think that, okay, this is really hard, I'm not going to try it at all. Try it out. If you don't understand, it's fine if you look at the editorial, look at it, solve it more. Because um, the only way you can get better is by practicing those problems, right? So I would just say practice trees, practice graphs, at least the most common ones, most common techniques, like in graphs, right? Flood fill, number of islands, these things are really like popular. So practice these things and you'll be good there.
Got it. And so one question that I get, right? So because you're talking about editorials and things like that. So a lot of people, right, especially when they come to lead code, it's probably a high level for a beginner, right? So and they lose the interest in coding. So one sort of advice that I give them, and I want to know from you if that's the correct advice, that I would say go for a platform like HackerRank or HackerEarth. Or would you want people to just stick to lead code and then watch YouTube and then come back, or should they shift to a media platform first and then come?
I think it makes sense the advice that you're giving. I think it makes sense to start with a platform like Hacker. At least when you, let's say, you're in college, you're in college first or second year, and then you kind of decided that I'm going to go on Python or C++. Now, HackerRank, for example, has a really good set of programs that for starting out, let's say for array strings, a bit manipulation and these things at the starting, finish those set of problems. At the end of the day, when you finish those set of problems, you'll be comfortable enough in the language, like I mentioned. And then at that point, you can switch to, let's say, lead code and practice and do those things.
Okay, so HackerRank also has this sort of facility where you can learn the language. So would you suggest that first?
I would suggest that first. I would say try out learning the language. I think they do have like C++, Java, and Python, and separate tryouts there. Learn the language using that. Then solve a bunch of problems there. But at the end of the day, HackerRank does have an interview preparation kit there. But apart from that, right, HackerRank mostly, at least if you look at the problems, it's more of a competitive programming side. It has like an interview section, and I would say if you're preparing for interview, stick to the interview preparation section. Unless you're really interested in programming, go ahead with it and solve a lot. But if you focus on only placements, get ready with data structures first. Like understand data structures and solve those problems and those kind of problems first, and then solve the other ones. That's what I would suggest.
We just have a question
Yeah.
from Aaron. So he says, I'll just read it to you.
Yeah.
So from a uni, there are a lot of uh, compute. One second, maybe my chat is a bit off. So to code via C instead of Python for placements, but I'm generally comfortable with Python. Should I continue solving questions with Python or shift over? Okay. So I think what he's trying to ask is there are a lot of employers who ask people to code in C, but he's very, very comfortable with Python. So should he shift over and make the trend or should he stick to
So,
what he knows?
by many employers ask him to code in C, does he mean like companies ask him to code in C when they come for placement, or is it for like something else?
Okay, there's a lot of emphasis to
Okay, got it.
code in C, sorry.
Okay, I think if you're comfortable in Python, stick with coding in Python. Basically, you're not losing anything out. If you code either in C++ or Java or Python, one of the big three programming languages, you're pretty good there. So since you already know Python and are good at it, I would suggest just continue with Python. You don't have to change your language just because more people are doing it or there's more like forcing to kind of do that. Just continue with your
Okay, and one thing that a lot of advice that I've got also from teachers and probably other people as well is that they always say don't learn Python first because you never really understand programming if you do it Python.
I, I wouldn't like completely agree with that because at the end of the day, right, Python has the same constructs as C and Java with the addition that it has a lot of these easy shorthand statements or it has a lot of these, let's say, slicing is much easier and reversing is much easier. But at the end of the day, queues, loops, structures, priority queues, maps, they work on the same principles in all the languages. So even if you use Python and you get it, I would say don't just, let's say, don't rely too much on things like list comprehension and stuff. Understand, do a normal loop. Like try to make your code as language agnostic as possible in the sense that if you write something in Python, at a later day, if someone from C++ or Java comes and reads your code, he shouldn't be wondering why is there like a -1 in the middle of the code. If that's fine, I'd say just continue with Python. It's perfect.
Got it. And yeah, one final question before I solve my problem is I've always thought of approaching solving problems in the way HackerRank, CodeChef, LeetCode is good.
If your focus, if your focus is to get placed, I would say if you're generally interested in computer programming, CodeChef is a great platform. CodeForce is a great platform. Hacker is also pretty good there. But if your focus is on getting placements, I would say focus on data structure and algorithms more than what you focus on computer programming. Because computer programming focuses on these kind of niche concepts like, let's say, segment trays, thread decomposition. Sometimes you have a lot of these ad hoc construction problems which are not as commonly as in interviews. In interviews, you would much rather get like a DFS modification than, let's say, an esoteric segment tree application there. So if you computer programming is more to like challenge your mind, it's like sport programming, kind of you can do it if you're really interested. But make sure data structures are sound, like really good if you want to do for placement.
Got it. So thank you so much for that. And I think I hope Aaron got his clarification for his doubts. And okay, so Sri just asked the doubt. I'll code and Athreya will be answering in the meanwhile. What does it take to become a good computer coder?
I would say in order to become a good content coder, I would say there's few things. Mainly, again, there is some overlap between, let's say, DSA and like computer programming in the sense that you need to be good at the language in both cases. But specifically to get good at computer programming, you need to be good at solving problems within a certain time frame, right? I mean, it's there for interviews as well. But let's say in a typical computer programming contest, you have 4 to 5 problems, and let's say you have a couple of hours to solve 4 or 5 problems. You have, let's say, one easy, two medium, two hard, something like that. And the problems are not that heavy on data structures, they're more heavy on how you apply your thinking skills in order to solve mathematical thinking, how you apply your mind to solve these things. So participate in contests, you have even a lead code. I would say a lead code's bi-weekly contest, even though it does have data structure heavy contest, you have a time contest that it's more like 2 hours or something where you solve it. Similar to that, CodeChef has CodeChef starters to solve like within 2 hours 4 or 5 problems. Code forces have the division rounds, division one, division two, division three rounds, where you have 5 problems. If you want to be good at CPA, start with code forces or CodeChef, solve the problem. I mean, try to solve the contest. Once the contest is over, let's say you manage to solve 2 problems out of 5. After the contest is over, look at the editorial for the remaining three and then upsolve. So upsolving is like a really good way to get better at computer coding.
Upsolve means, I just guessed. So upsolve means like when you come out of the competition and you're just trying to solve a hard problem without considering the time, is it?
Slightly the same, but it's more like once the contest is over, you're right. You hand back the problems that you didn't solve it because of the time constraint or something else. You try to solve it. In case even you're taking a lot of time or you don't even know the concept. Let's say that it's a concept regarding rerouting of trees and you've never done it. So the chance that you would do it by yourself, take a lot of time is lesser. So try for 1 or 2 hours. If you don't get it, look at the editorial. Upsolving, the main thing upsolving is you need to know how to solve those three problems that you did not solve earlier. So that is the main like thing there.
Makes sense. So thank you so much for the question. I think you got the answer to it, and please feel free to keep asking this question, guys. So I will go to the next problem now, which is the longest consecutive subsequence, right? So what is this problem basically saying? So just give me a minute while I set my screen up, right? So yeah. So let's just read the question. As I always take is the same approach. So we always just read the question, try to figure out what exactly they're asking, and if we can't understand, we look at the inputs, right, to get more intuition as to how to solve the problem. So given an unsorted array of integers, now return the length of the longest consecutive element sequence. You must write an algorithm that runs in O of n time, right? So okay, now uh, let's not look at the second line of the code. Okay. I mean, second line of the problem. Let's just look at the first sentence. It says, given an unsorted array of integers nums, return the length of the longest consecutive element sequence. So what do consecutive elements mean? So it's like, for example, we have 1, 2, 3, 4. That's a consecutive sequence, right? So and here 100 doesn't have anything around it. Like we don't have 99 or 101 or things like that. Now again for 200 we don't have 199, 201, nothing like that. So a consecutive sequence means all these numbers are split by 1. For example, for if I had like 1, 2, 3, but instead of 4 I had 5, right? So that's not a 1, 2, 3 is a consecutive sequence, one consecutive sequence, and 5 is another consecutive sequence, right? Now what would be our brute force approach to solve it, right? That's I think whenever we see constraints, right? The first I would also always say when you look at a problem, just try thinking about it and try solving it in the most brute force, naive approach possible. Because at the end of the day, I still feel you're solving that problem, and maybe the techniques you learn later. So, what would be a brute force approach, right? So, what I would do is for a problem like this, in brute force way, I would uh, I would look at a number like let's say we had a number like 1, 2, 3. Uh, 1 second. Sorry about that. So yeah. So let's just look at let's say we have an array like 1 to 100 and 4 and things like that, right? So let's say this was our array, right? So what I would do is I would just iterate through all these elements at the start, and then first I would capture this element 1. Then I would try seeing, okay, what is the next element? Is 1 plus 1 there? 2. Yeah. Then I would try finding, okay, is 3 there in this list? And then 4, and then 5, and then so on, right? But now the problem is that we are trying to do this for each and every single element inside the array, and that already starts looking bad, right? But now, what if I was able to sort this array, right? So the same numbers 1, 2, 3, 4, 5, and 100, right? Now the whole problem becomes very, very simple. When I reach an element, right? As long as I find a number that's just one greater than it, I can keep increasing the length of the sequence. So 2 is just one greater than 1, so I increase the length. 3 is one greater than 2, then I increase the length of the sequence. Then 4 is one greater than 3, and then 5 is one greater than 4, then I increase the length, right? But now I see 100 is not one greater than 5. So at this time, what I do is I put something like max length is equal to max of max length comma curl right? So curl is the current sequence length we have, and max length is the maximum length that we're maintaining inside our array, right? So now that by sorting the problem, it made our whole job so much easier than it was, right? But now the thing is, why did we actually even think about sorting the array, right? So now, the problem tells us that we're not supposed to use a sorted array. But if we have some intuition, why did we even adopt this approach? Is very simple, right? So we wanted to quickly find out if the consecutive element is there in the array, right? So if I know in my ith index I have this element 1, I want to quickly find out in just in like an O of 1 approach, what is 2 in the array. And again, when I'm at 2 in O of 1, I again wanted to find is 3 in the array, and so on and so forth, right? So that's how I want to do. But if you think about sorting itself, it's an n log n approach. And if you look at what the question says, we have to do it in O of n times. Okay. So can we think about anything, any data structure, right, that could make up this lookup operation on this unsorted array, O of 1, without actually sorting it? Do we have any data structure? Absolutely. We have something called as hash sets, right? So first, let me just change the coding using the Python environment, and let me also just increase the font size. I think next time when you're solving the problem, to maybe we have to increase it. So yeah. So let me just create a number set. Num set is equal num set. Okay. Set of nums. Okay. Now my idea is going to be very simple. Okay. So let us say I'm just putting all these starting at a certain element. I want to find what is the consecutive like sequence that it forms, right? So for example, if I have one, right? So starting from one, I have this sequence one, two, three, four, and five, right? So that is the maximum sequence. But now, for some reason, let's say I started at two, right? I have all these numbers in my set. Okay, and I started at 2. And yeah, I would find 3, 4, 5, and I would get this sequence length as 4, right? But actually, if you see in my set, there was a number 1, right? Which is actually the start of the sequence. So, my first idea is to find out which element starts such a sequence. So, somehow I should be able to tell if it's 2, it's not the start of the sequence, but if I'm starting from 1, it is the start of the sequence. So, how would I do that? Very simple. When I go to a certain element inside the array, I would simply check if that element minus 1 exists inside the set. For example, what is 1 minus 1? 0, right? Does 0 exist inside our set? No. So this definitely means 1 is a start of some sequence inside the array. 2. Let's take an example of 2. Does 2 minus 1 exist in the set? Absolutely 1. So that means 2 is not the start of the sequence, right? So this is our basic logic. First, what we do is we find the start of a sequence, and then we try and find if all the consecutive elements are there, and then we keep increasing, right? So let's just apply this logic just for our confirmation to the number 100. Is 100 a start of the sequence? Yes, but why do we know it? Only because 100 minus 1 does not exist in our set. So this is our basic understanding of this problem. Let's just code it out, right? So as you remember, we just had this set data structure just to do these lookups in O of one time. So, okay, now let's just get to the coding, right? So for val in, before that, I should also have this sort of indicator, which will store my maximum length inside the array. So for val in nouns, okay, if again, so my first thing is to find if a certain value is the start of the sequence. And how do we do that? Very simple. If my val minus 1 not in num set, that means yes, this value is the start of a sequence. Then what do I do? So the current length of the sequence would be 1 because the value is there. Now what I do is while val plus cur length in num set, cur length plus equal to 1. So again, very simple. If you have one as value and one plus one, two is also in the num set, what we do is we just increase curl by one. So the next time we check for three and so on and so forth, right? So then we keep building our length up. Then finally, once this thing is done, so what we have to do is just max length is equal to max of max length, curl length, right? And finally, we just go here and return our max length. So let's just run this. Yeah. So, and let's just submit this also. Yeah. So the basic intuition of this problem was just finding out why we sorted it and like why it was so necessary to sort the array. And we realized that we sorted the array just to find these elements much faster, right? In O of one time. And we had this data structure set which allowed us to do that. So we put all these elements into a set. And the next bit of intuition was finding if a certain element is actually represents the start of the sequence or not. And once we found out that element represents the start of the sequence, what we do is we just keep checking if the consecutive elements are also in the array. And as long as the consecutive elements are also in the array, we just increase the curl length. And then finally, we print out the maximum of all the lengths that we found. Yeah. So that is the intuition of this problem.
Yeah. So Ashwin has asked a question. He's asked, is it good to stick to a single platform, LeetCode or HackerRank, or practice with multiple platforms? If yes, how many different platforms?
Mm.
So I would say that again, if your goal is only placement, preparation, you'd be good with just two concepts. Let's say HackerRank that you use to get familiar with the language, and then you practice it with it, and then lead code just for data structures. So lead code, I would say, is self-sufficient for data structure preparation. Let's say you want to practice DP or strings or arrays, just filter out of that, start with a couple of easy problems, and go ahead with medium problems and just solve it. Actually, that's more than enough for DSA preparation. And don't use too many platforms, I would say, because I've seen people do put through courses, HackerRank, Hacker, Elite Code, Leaks, Coding Ninjas, and everything. And at this point, if you use that many platforms, right, you also get lost. You won't have a proper, let's say, continuity in anything. So, if goal, I would say again, is DSA. I would say just two is more than enough in that case. So,
Two, okay. So HackerRank and LeetCode. So one that you start out with, and
yeah, and then
LeetCode
they
that
go
you
for just data structures and
okay.
everything.
One question, because a lot of my friends are in the placement season almost, right? Or they just go into placement season in 6 months. 6 months left. What is your strategy?
6 months left, I would say. If you know the language, it's great. Otherwise, just spend like a month learning language. Otherwise, I would say start with basic preparation. Okay, someone has said that we are not audible.
I think, what about now?
Is it better now?
I think it just has some delay and
Okay.
come on. We're so sorry about that.
Yeah.
Yeah, I think the question was, yeah, what does one do with 6 months left?
Yeah, I would say if we have like 6 months left for preparation, first focus on getting the language ready, as in language and not only for loops or things like that. I meant the language as in if I tell you implement, let's say, not implement, just use the priority queue from collections in Python, you should be able to use it. Then you should be able to use maps. You should be able to define your tree or linked list structure and then solve problems. Get to that point first. Then just Google like the top problems. Let's say you have multiple lists right now, 2020, you have multiple lists that people have just curated. Even LeetCode has its own like 175 lists, and you have multiple different things. So choose any of the lists that you want. Get started with it. Main goal is not to kind of mug up the solutions. It's more of can you understand the solution so that if you get a new problem, can you apply the same technique in that new problem as well? So that should be the main goal. So you have to kind of make sure that you practice those, like practice arrays, binary search, DP, trees, recursion, so on and so forth. Get done with those problems and the common techniques in each of those are so you can prepare in whatever way you want, and it's not necessary that everyone has to do the same set of problems. Depends on where you're starting, what your current level is, and what you're targeting for. I would just say make sure to cover the common techniques, and that's easy by saying you send to Google search and just see what are the common graph techniques. You cannot get it there. So just proceed with that way. I would say. And 6 months is, I would say, more than enough.
Yeah. Yes, 6 months is fine. Okay. Has anybody made it to farm with 6 months of
Yeah,
prep?
I'd say a lot of people kind of they take 6 months or 8 months, and there have been people who take it less, or let's say 3 months or 4 months as well. But I'd say 6 months is much more than enough to kind of properly, if you even pace yourself really comfortably, it's enough for you to like get like fang ready, I would say.
Got it. So I think now we can, the audio is also better now. That's what I've heard. And one question that Aaron had in the middle is a question. So consider that list one, two, three, four. Yeah, absolutely, Aaron. It works for that also because we're putting everything in a set and we're just looking up elements. So the ordering doesn't matter, right? So it almost acts like very similar to our sorted logic when we put everything in a set. So yeah, over to you, Aaron.
Yeah, so let's look at the next problem here. The next problem is find the smallest element that is greater than the target. So we're given a letter array here. If you look at this letter list, right, we're given characters here, and we are supposed to find out the smallest character in letters that is lexicographically greater than the target. So if our target is A and our array has C, F, and J, what is the smallest? If you look at it, right, what elements in the array are greater than A lexicographically? That lexicographically greater just means that if you have two characters A and B, B comes after A in the sorted order. So B is lexicographically greater than A. So if you look at this letter array, right, I would say C, F, and J, all these three elements are greater than A. So all of these are lexicographically greater than A, but the question asks you to return the smallest character that is lexicographically greater. So because C, F, and J are all greater than A, the smallest character that is greater than A is C. So that is why the output is C in this case. So let's look at kind of approaching this problem here. Second. Let's see. So Let's take an example, our own example. Let's say you have C, let's say you have D, and also given that the array that you have here of characters is given to be sorted. So that property is there. Whenever you have this sort of sorted structure, you know that you can use binary search. So let's just look at it in that case. Let's say that this is our input array CDF, and let's say the target, right? Let's say that the target is E. Let's say our target is E, and we need to find out the smallest element that is greater than the target. So if you look at it, right, C is definitely smaller than E. So that is not the case. So this isn't even an answer candidate. Is D greater than E? Yes, D is I mean D is also not greater than E in this case because D comes before E basically. So this is also smaller. And now is F greater than E in that case? F comes after E in the dictionary order. So F is kind of greater. So the smallest character in this array that is greater than the given target E is nothing but F. Now let's look at another case. Let's say you have A, then let's say you have B, let's say you have F, let's say you have G, and let's say you have E. Let's look at this case. You have A, B, F, G, and E, and the target that we're looking at, right? Let's say that the target is C. So this is kind of the case to understand. And let's say we have a certain, how do I put it? We have a certain condition, and my condition is I want to check is the current element I'm looking at is my A greater than C or not? My A is not greater than C. Is my B greater than C? My B is not greater than C. Is my F greater than C? Yes, my F is greater than C because F is the element that comes after C. Is my G greater than C? Yes, my G also is greater than C. Then at the end, I mean, this won't be the output because it's like let's go guaranteed that it will be sorted. So let's just say A, B, F, G because it's given the input that it's guaranteed to be sorted. So this is our input, and two elements here are lesser than C, and two elements are greater than C. This is what it is. Our goal is even though F and G both come after C in the dictionary order and they're greater than C, what is the smallest element that is greater than C? It is F. So F is kind of our output in this case. And if you look at this no, no, yes, yes, right? Let's say instead of no, no, yes, yes, let's have them as 0, 0 and 1, 1. All we are trying to find out is given a sorted array of zeros and ones, can you find out the first one here? That's what the problem reduces to. So if you look at, we can try coding it out using normal binary search. And what will be the logic? Let's just look at it in like the next one. One second. Yeah, so let's just look at it. So let's just say you have 0, 0, 1, 1, 1. Let's say this is the one that we have, okay? Because our problem essentially by the condition that we had, it reduced to this format of having zeros and ones. If you want to find out the mid, like the first one, right? What will you do? If you encounter a zero, you know that you want to move the pointer to the right side. What does binary search do? It tries to eliminate either the left half or the right half in order to get you a log of n runtime. If zero is encountered, if zero is encountered, what does it mean in the context of this problem? It specifically means that you have encountered a character that is lesser than the target value. If this is the case, you want to move right. And how will you move right? You just move your low pointer to be mid plus one. As in, ignore the left half, move your low pointer to be middle plus one. Only look at the right half. Otherwise, if one is encountered, right, this is the place where you kind of need to be careful because some people say that if one is encountered, we just return the answer, which is wrong in this case because there are multiple cases where one is encountered. So let's say we have a variable, store the index where this one is encountered, and then go left. And why do you go left? Because there can be another one on the left side, smaller one on the left side. So how do you go left? You just do high basically is middle minus one. So this is kind of the approach, and we'll just look at coding it out as well. So let's get started. Yeah.
One second,
Oh
you
yeah,
can increase the size of the font. So sorry about that.
yeah. I think it's good. Yeah. So let's just get started with this. So we're finding the left size, and then we have our low pointer, which is basically 0, and we have our high pointer, which would be size minus 1, size minus 1. And then a normal binary search starts. So you check while low less than equal to high. You try to find out the middle, which is nothing but low plus high by 2. And let's say I also have an answer variable that stores the index of the first element that is greater than the given target. Now, what is my condition? If letters of middle, right? If this is lesser than the target, this is the condition where I just mentioned it is the zero condition, in the sense that if I'm encountering a character that is lesser lexicographically than my given target character, I have to move to the right. I don't have to do anything in that case. So I can directly do low equal to middle plus one. Otherwise, right? Otherwise, this means that this is a candidate for my answer. As in, the character that I'm currently looking at is guaranteed to be greater than the target. I do not know if it is the first value greater than the target, the smallest value greater than the target, but it is a candidate answer. So I will store this particular index in my answer variable, and I'll say, you know what, go left. And how do I go left? By just doing high equal to middle minus one. This is what I do. And one thing that we need to look at, right? There is also a case where, let's say you do not find, for example, in this third example here, letters is X, X, Y, Y, and target is Z. Since you did not find any character that is greater than Z in the given array, it tells you to return letters of zero itself, which is nothing but the first character. And this already gets, that's why I had initialized this as zero at the starting. So if I just return, right? If I return letters of answer, it also handles that corner case as well. Because in case I do not find anything here, it would default to that. So let's just run it and check whether this will work. So let's just look at it. Here in this case, okay, let's just look at it in that case. What happened here? I would say we calculate the middle and then, okay, yeah. So in this case, the problem, this is a nice corner case to kind of look at it the wrong answer, because here, right, I checked only strictly lesser. So it kind of defaulted. And if you look at the case where it failed, right, let me just pull that up again. This kind of really nice. Do I pull it up? So if you look at this case, target is C, it returns C itself because the condition here was lesser. Yeah, that's why we don't have a specific one. For example, if we just change this here, it'll go else. And because what was the problem in this case? We did not have the lesser than equal to. So the else condition was triggered even when we have something equal to the given target. So if we just have lesser than equal to here, it will change. And I think this should, let's check. Yeah.
So that this is waiting for it. Perfect. So that was the solution to uh, the greatest character. The character greatest, the smallest character greatest. That was quite a word jumble. But yeah, so now we've got two very, very, very interesting questions from our viewers. One of them asked, is as an SDE, do you have any coding experience that is as interesting as lead code, or is it just copy from Stack Overflow? And as a follow up to that, also, I'll ask.
Okay, so I would say in my case, I code in Swift mainly, so I do iOS development in that case. And for better or worse, for the latest releases, for example, you don't have that much documentation, so you kind of have to do sort of hidden trial in that case and make sure that it works. It's also good in the sense that let's say we kind of make sure, let's say if there is a new iOS release, we have to make sure that it's compliant and it's working on the new devices as well. So once Apple releases their new, let's say iOS release, we need to make sure that our app is compliant, and that happens really fast. So there is not enough time to catch up between the new release and for it to have enough documentation for us to help in that case. And also, I would say in this app developer space, if you're working on stuff like accessibility and other things, the documentation anyway is not that much. So I would say there's more scope in this way. You're forced to kind of find out the solution yourself and solve it. But yes, it's not, I would say, it's not as interesting as lead code. But I would say it's much more fulfilling in the sense that if you're doing lead code, you're solving a problem, you're learning an algorithm, it's fine. But in actual production level code or developing apps, right? For example, SharePoint, the thing that I code on, is used by 1 million people. You know that something that you're coding is used by 1 million people. So I would say it's much more rewarding in that sense.
Yeah. So another question. You guys can talk. You can talk about it maybe because Microsoft owns or even is responsible for GPT, ChatGPT. So the question is, do employees use ChatGPT to code?
So I would say ChatGPT, right? At least the state it is in right now. You can't, you can give it a prompt, and because it's a generative AI model, basically, there is, it's super helpful. But I would say people, as developers, in max of the people I've seen, they do not rely on ChatGPT because they use it for helping in certain tasks. Let's say you're writing unit tests or something, right? Or let's say even I'm trying to write a unit test, I can put in a prompt and I get a template ready. As in, you know what? Something comes out. So it's up to me to kind of make sure that what I get is correct again. Or let's say there's a huge prompt and give something. And in most cases, we do this experiment where we're just kind of trying out how far we can push productivity. And at some point, right, it starts giving things that doesn't exist because it doesn't have enough context in that particular niche problem. And we're solving problems that are more like when you have expertise in that area, ChatGPT is not that useful because it doesn't have that much context. I would say we have this we discussed with our employees and stuff, and one person was like he uses ChatGPT because it's so much faster in drafting, let's say, professional emails and changing it. Those things is really helpful. Or let's say a unit test where you have a starting template, and then you can kind of you get some sort of manual effort that is saved. You have to start from scratch in that way, but not completely like
Yeah,
that.
I think makes sense. When you go above a certain level of expertise, maybe GPT does not have access to.
It doesn't have that context of to provide you an exact answer in that case.
Uh, yeah, but as you said, right, I feel like there is a certain point, like at least it's increasing probability of some.
Exactly. I would say it's insane in the sense that at least things that normally, right, even right now, for example, if I had to draft an email or look at the main points of something, I can just look at ChatGPT and look at the summary immediately. Instead of like saving me an hour of time itself, like even for documentation, let's say, you have to read documentation. Instead of reading to 20 pages, I can just skim it through and see what are the main things. And then if it misses out, I can at least go back, but I have a starting point where I can use it.
Okay, and one other question that we had is which is harder, the preparation or the interview itself?
I would say
I mean, I think the funny answer to here is if you make the preparation hard enough, the interview is easy. If your preparation is easy, the interview gets hard.
that's a nice way to put it. But I would say preparation is easier only because if I had to choose, right, I would say preparation is easier because you're studying at home. You have every like comfort. You don't have a timer. You don't even if you put a timer, you know that nothing's gonna happen when the timer runs out. So you know you have that sort of leeway with yourself. But in an interview, it's more of your performance in those 45 minutes that determines whether you know to proceed to the next level. The stress at that point is a lot more, I would say, than even if you have a easy question, then the stress is because you need to perform in that 45 minutes, I would say.
Yeah, definitely. I think when something's on the line, I think it's easy because you don't factor in the stress and things.
Exactly.
So, thanks for the question, guys. And now we'll be proceeding to the last question of the day. So, please feel free to ask any sort of questions that you have, and even if it's fun, and you can ask, right? And I think we're just here to talk about them. And for Athreya is here too, so he can give any sort of family advice for to all of you. Yeah. So let's just go to the last problem for the day. So this is a very, very, very popular problem, the threesome problem. So let me just, before that, let me just increase the size of the font. Think there was probably a default setting that I could have changed, which I haven't. So yeah. So okay. So this problem, I think you would really be helped if you had some idea of what the twosome problem was, and it's not necessary at the end of the day, but still, at the end of the threesome is just an extension of twosome, right? You have two numbers to add up there, and you just have three numbers to add up here, and that's the only difference I would feel. So let's just look at the problem. What does it say? Given an integer array nums, return all the triplets nums I, nums j, nums k, such that I naught is I mean, there are three separate indices of numbers, and so when you add all of these three numbers up, they sum to zero, right? So three separate indices inside the list you have to extract, and then I mean three numbers at three separate indices, and you have to tell if they add up to zero, and you have to give all the combinations that do that. So before I confuse you more with my talking, let's just look at the input of and try to analyze the problem. So here we have this sort of nums array with -1, 0, 1, 2, -1, and -4. So let's just look at all the pairs that, I mean, all the triplets that add to 0. Okay, so let's look at the first one. So I take -1, okay, and then let's say I take 0, right? So now my idea is to search for what? Number 1, right? Because when I take -1 and 0, I have the sum as -1. And ideally, I'm trying to look at a number that makes it 0, right? So we have -1, 0, and 1. Perfect. And now let's just look. Zero again is the old triplet minus one and one, but yeah, that's already exhausted. Again with one, I don't find any other triplets that add up to zero except this one, zero, and minus one again, which is already exhausted. So the only other pairing that I can see here is if I take this minus one, then I take this minus one, and then I add two to it. So minus one plus two is equal to zero, right? That is a problem. Well, at least our human understanding, it seems like it's a very tricky problem, but we can solve it, right? Just by looking at it. But now the main trick is how do you actually get a computer to solve this, right? So, and it becomes like, I would say, exponentially harder thinking in that sort of direction, right? So, one way is to possibly generate all the combinations of all the triplets of three that you can get, and then find only the distinct triplets of three and then add them up and find okay what sums up to zero. But that seems like that's not that's computationally probably too complex for a large array size, right? So now let's just get some intuition into this problem. So let's open the notepad, right? So now, is there any modification that we can do to this array that can make this problem a bit simple, right? So for example, right now, I was searching for minus one, then I got zero, then I was searching for something that made this whole minus one and zero into one, right? And I had to basically scan through the whole array to find that one. So can I kind of place all these elements logically inside this array so that I can make this whole finding process easier. Yeah, and if you think about one sort of strategy that we had in like two problems back was sorting, right? Sorting made the problem much easier. So let me just sort all these elements. So minus one, minus four here, uh, and what else? Minus four, minus one, minus one, zero, one, two, right? 0, 1, 2. Right. So now what we do is we're going to use this two-pointer approach. Okay. So first, I visit the first element, and then I put my two pointers here, L and R. Right. So L is my left pointer and R is my right pointer. Right. So now all I have to do is find out using these two pointers and shifting them around the array. If I get these triplets of 3, minus 4, and something that the left pointer points to, and something that the right pointer points to, if that becomes 0, then that is one solution to the problem. So let's see how we would do this. So here, right, I have minus 4, minus 1, and 2. So what is the total sum? Minus 5 and 2, that is minus 3. Right. So on now I'll use some intuition, right? We have to move the left pointer or the right pointer, right? So now I have minus 3, but I'm trying to get to 0, right? That is where I start printing on the result. Now, should I move my left pointer to the right side or should I move my right pointer to the left side? So should I increment my left pointer or should I decrement my right pointer? So if you just think about it, right? Because this array is sorted like this, if I increment my left pointer to the right side, I'll always get a non-decreasing sum. So if I had minus 3 here and I increment my left pointer to the right, there is no way I would get something lesser than minus 3, right? So let me just increase my left pointer, right? Is now the sum equal to 0? Absolutely not. So then I again increment my left pointer. Again, is the sum equal to 0? So we have minus 4, 0, and 2. 2, I mean minus 2, which is again not this what we want. Then let's look at the again we increment the left pointer. Minus 4, 1, and 2, right? So yeah, this again. So this results in minus 1, right? And now I can't increment my left pointer further because I have to find three distinct indices, right? So now my minus 4 is not a, it won't lead to a possible solution, right? So now let me fix minus 1, right? And as I, and then put left pointer here and right pointer here. And now let me just quickly take you through the same approach. And here, right, it's quite obvious because the very first index, if you see, minus 1, and I add my element at left pointer here, so minus 1, and what's at right pointer 2. So if I add minus 1 plus 2, I get 0, which also gives me a potential solution, right? That's done. Now what I do is, once I found a potential solution for this case, I immediately don't exit. I simply increment my left pointer to 0, right? Now I have minus 1, 0, and 2. So now the sum is actually the minus 1 plus 0 plus 2 is actually 1, right? And now what was the intuition? If I had a sum greater than 0, should I increment my left pointer or decrement my right pointer? It's quite intuitional, right? So I just have to decrement my right pointer. So now what I do is I decrement my right pointer. Now if I add minus 1 plus 0, minus 1 plus 0 plus 1, I get another 0. So this gives me another potential answer. So this is how you solve the problem. Right now, I think all the solutions for this sample test case are exhausted. So we don't have to do this problem further. But this is the intuition of this problem. First, we sort the array. Then we fix one element. And then we use the left and the right pointer and manipulate them and find the other two pairs of the triplets. So let's just code out the solution. So as I said during the solve, so the first thing is first step is obviously sort the array. Then we'll have this solution list simply to maintain the list of solutions that we find. So for num, sorry, I in range, okay, len of nums. So basically what we're doing is we're going and fixing every element of the array as we discussed earlier. So then what we do is, okay, so one case, right? So the one case is when, let's say I only have all positive numbers, right? So if you remember, this array is sorted, right? And let's say I get fixed at a positive number, right? I fix at a positive number, and that means L is pointing to something to the right, and R is pointing to the. Uh, I just clear it out so it looks better. One, two, three, four, five. Okay. So I is fixed at a positive number, and L is fixed here, and R is fixed here, right? So if I is already fixed at a positive number, there is absolutely no way I can create a sum of sum equal to 0, because the other two elements to the right of it are obviously greater than the result that I'm seeking. So greater than 0. So at that point, what I'll do is I can just, if nums of I greater than 0, okay. So what I basically do is just return the solution at that point, saying that, okay, there is no possible solution. Now there's another case if I is greater than 0 and nums of I is equal to nums of I minus 1. Okay, so then I just do continue. And this is again very simple why we do this. If you read the question, right, they're always asking us to find unique solutions, right? Unique indices. So if I go to two numbers which are basically the same, 1, uh, 0 and minus 1, something like that. So once I've already found with this one and this 0 and minus 1, I shouldn't find the same pair for this one too, right? So that is basically why if uh, the next number is equal to the previous number, we just simply skip this whole process, because if there existed a pair triplet that led to a 0, we would have found it. So that is our intuition there. And again, here comes our left pointer, and here comes our right pointer. So right pointer is basically the index of the last element. So now what we do is while L less than R, sorry, while L less than R. So that means my left pointer is still before right pointer. So I just uh, yeah. So what I do is right here total is equal to nums of I plus nums of L plus nums of R, right? So that's my total. And now again we go to our basic intuition. So if total is less than 0, what we do is we shift the left pointer to the right. L plus equal to 1. L if total is greater than 0, what we do, shift the right pointer to the left. So decrement the right pointer. Else, that means we have a zero sum. So at that point, what we're supposed to do, we just append this triplet to our solution. So Python allows us to do this very, very easily. So I nums of L and nums of R, right? So now that we have appended this solution, but does our solution end here? No, right? So we once we have done this, we also have to make sure that we don't get stuck in this infinite loop where we just keep appending this solution. So what we do there is L plus equal to 1. So once we have appended this possible solution, we increment L. But here's another thing, catch, while it's very similar to what we had at the start here. When I told if there are like repeating elements, right, you might get stuck in this sort of loop where you're just, I mean, not you start getting duplicates inside the solution. So as long as while nums of L minus 1, while L less than R, and nums of L minus 1 equal nums of L plus equal to 1. So then finally what we do is we just return the solution, right? So let's just run this. Local variable u assigned before at 921. Ah, so that's something that I do very often. I sorry about that. Yeah, let's just submit this code. Yeah, perfect. So that is a solution to this problem, and I know there are probably other ways to do this too. So what would you say? Like, should every like when you look at a problem like this and you solve it, do you really go back and sit and try to find a more optimal solution?
I would say at least for this problem, right? Like you mentioned, initially the thing that you mentioned for brute force is generate at least reply and kind of find out is not okay and do it. I would say that is again kind of you have to brute force it. You just have three loops, right? And then you can submit and that's more like active. This again is an optimization because the worst case will be n squared, right? Because you're just fixing the start index, and then for every start index, you're trying to do a low kind of approach basically for LMR. So this n squared. I would say as long as your solution is of the same order of complexity as the most optimal one, in this case, right, n squared is much better than n2, but I would say this is kind of the standard. So keep with that. I wouldn't say go to like, for example, even for a problem like longest increasing subsequence, right? There is a DP approach that you can do it using the for loops. But there is a more sophisticated approach where you can use binary search or segment trees and get it to n log n. I would say that is so rarely used that you would not even in an interview, if you had to justify how did you come up with an approach like that, it'd be so hard to explain how did you get in the span of 40 minutes how do you like arrive at that, right? So I would say as long as your solution is pretty much one of the optimal solutions that is there, then I think it's totally fine there.
Got it. So yeah, so with that we are done. For, I think we just have one question now. But if we said, can we add the statement if set L? Uh, I'm not sure as to what this construct actually is. Maybe because I'm not very well versed with that. But I'll definitely get look at it and get back to you, Adam. So thank you so much for the question. So yeah, now coming to this, one question that I've always had is, when you're looking to make it into a big company, is projects more important or DSA?
I would say if you're a fresher, or even if I'd say you have like a year of experience, I would say DSA has more importance, at least I would give it, than projects because if you have really good projects, right, all that lets you do is get into the interview. Let's say that it's more of a criteria, something on your resume to let you get within the interview opportunity, right? You really get open source contributions, and let's say really get projects. It's really good. It elevates your resume. Have either one or two things. Either have like really good projects or have really good like content coding or like DSA. One of these two things, DSA or yeah, and you have both. So then after that, you got an interview call, right? From that point, pretty much it's only DSA. So if you have four rounds, out of which three are mainly DSA, I would say that has much more difference because that is the one that actually decides whether you're getting in or not. So I would say in that case it's more.
So thank you so much. And any other tip?
Yeah.
Yeah.
One thing I would say is initially the first one, I didn't have the ability to explain the first one
Okay.
why the big heap approach there. So I think we can just go over that.
Yeah, sure.
For 2 minutes and we can go there. Let me just use it here itself. I think the thing, right? For example, if we have like a sorted array, and let's say case 2. So let's have the indices here. We have 0, 1, 2, 3, 4, and 5. So if k equal to 2, what index if I have a sorted array, what index am I looking at for the second largest? The index 4, correct?
Mm.
So index 4 at the element 5. So essentially n in this case is 6. There are 6 elements that I have, correct here.
Mm.
And if my n is 6 and my k is 2, right? I'm essentially looking at something like n minus k. Right? This is what I'm looking at. If my n is 6 and my k is 2, I'm looking at the fourth index to find out the kth largest. If it's already sorted, this is of course an O1 lookup. I can just see what is my element of the n minus kth index and I can just return it. There's one way. Now, The most intuitive way I would assume is using a max heap because they do ask you to find out the largest. So when you put every single of these six elements into like a max heap, what happens is you have some structure where you have six at the top of your max heap, and you have some sort of other like other elements somewhere. You don't have to worry about this. The property is this initially is at six, and because you inserted every single element, n log n is your complexity already. Because for n elements, you did log n time for inserting one element into your heap. Now you del because this is the first largest essentially, and you want the second largest. So you delete this, and then now six is deleted. The heap kind of internally restructures itself to get the next maximum out of the top, and next maximum is here. So after doing one deletion, what is at the top of your max heap is nothing but your kth largest element. This now is n log n because for inserting n elements itself is n log n time. And then how many deletions do you do in the worst case? You do k minus one deletions. Let's just call it k deletions. And so it's k log, it's k log n because the size of this heap is log n, and then you do k deletion in that case. This is kind of the intuitive way. I would kind of want to go over a couple of minutes about why the min heap approach also works, right? Because it's not that simple to understand. I would say, let's say that we have 1, 2, 3, 4, 5, 6. And let me again write this, right? And let's say my case 2. So the main approach in the min heap is I do not want my heap size to exceed k. Or in the other way, right? If you look at it, second largest is basically this index 4, like we saw, this is n minus k, correct? If I ask you how many elements are there before the element that I want to return, so that is basically four elements are present before the element that I want to return as the answer. My answer should be returned element 5. Before that, there are four. So somehow can I maintain a min heap where I do four deletions of the four minimum elements in order to get the second largest? So let's say how we do that, right? First, I insert one into my min heap, and let's say this is my min heap. I insert one, and this one is currently my minimum. Then I try to insert this is like two largest, so I want to make sure that my heap size is always two. So next I insert the next element. My next element is 2, right? So I insert 2 in my min heap, and then the minimum or the root of the min heap still becomes 1. Nothing changed there. Then I insert 3 into my min heap. I mean, it can be in any order, but it's just easy if it's like sorted. But any order kind of works for any kind of different permutation of the input. So let's say I insert 3 now. Now, min heap, again, the root is still 1, and the condition is violated. What is violated? The size of the min heap right now is greater than k. Because it's greater than k, I can delete what is at the root of my min heap. So I delete this element directly, and since I deleted this element, the min heap internally restructures itself, and the minimum now, the root of the min heap is now pointed to 2. And what did I delete? I deleted this element, which will never be part of my answer. It's kind of the first, like the minimum, in this case, the first minimum. But it's essentially one of these four values will be deleted in the first iteration, given any order of the input. Next, what do I do? So now after 3, 4 is the next element. So I insert 4. And now again, my root of the min heap remains the same. And then because I inserted 4, again the property is gone, right? That means my size exceeded k. And so I can delete the root of the min heap. And now my root comes here. So but if you continue this procedure, I essentially make sure that these four elements are deleted. Let's say the input order was different, right? For example, this is kind of a simple case where you can just tell me that, I have it as sorted, so it makes sure that it's deleted. But let's just look at this case, right? Let's take a nice case that we have 4, 3, 1, 2. Let's say there are four elements. And we want to find out the second largest. And this is not sorted, obviously. The first largest is 4. The output that we want to have in this case is 3. Correct? Now let's see what happens here. Initially, my min heap is empty, so I try to insert elements. So I would insert 4, and the 4 is currently the minimum element in my min heap, or the root of my min heap. Next element is 3. I would insert 3, and now the min heap will structure itself, and minimum root, the root element will now get changed to 3. Now I try to insert, now the property is again I have two elements, so no problem. I try to insert one more element. I try to insert one, and the min heap internally restructures itself, and my min heap is now at here. And now because the property is, extent is violated, that means the size exceeded k, of the min heap size exceeded k, I would remove the minimum like element or the root element of my min heap. I would end up deleting this. So if you now think about it in a sorted fashion, right? 1, 2, 3, 4. I want 3 as my answer essentially, and what is the first element I deleted? It is 1. So how many elements do I have to delete from the minimum in order to get to 3? It's 2 elements. If you continue this procedure, 1 and 2 will be deleted and 3 will be there.
Whatever is at the top will be at the
And what's at the top will be like the kth largest element there. So
That's such a good approach. Yeah, and I would have never thought. I would just think, okay, max and look at the kth largest, just max equal to. So it's so great understanding that, yeah, there are many ways to solve it. And I think if you solve it in even the reverse way, it deepens your understanding of it. So, yeah. So I think we have one question. What is the time limit you keep for each problem that you solve?
Oh, nice. I think ideally in an interview, you need to solve two problems within 40 to 45 minutes. So I would say taking by that, you need to read a problem, you need to discuss with your interviewer, and you need to give working code within, let's say, 20 minutes, which means, let's say, you have 5 minutes for understanding and discussing, 15 minutes for coding. So I would say if you're able to solve medium level problems in 15 to 20 minutes, you're set there in that case. But this is like if you actually are doing mock interview in that case. While you're learning, it's fine. I would say, for example, when I first learned tax class and like BFS and stuff, right? I don't think it's kind of natural to expect someone to do it within 10 minutes initially while learning. So it's fine if you take more time while learning, but make sure once you learn the concept and doing similar problems with the same concept, that your time limit for solving any problem of that concept comes within 15 to 20 minutes.
Got it. And I think you also told me once that it's not just about solving the problem, but being very like explaining it well and you're
Right.
able to do. So ideally, you would look for something shorter before the interview, then go into the interview.
I would say, yeah. So I would just say that in an interview, if you, it's not only getting the code right, like you mentioned, it's how well you can communicate your code, how like readable is your code. For example, if your code is is slightly longer, it's fine as long as it makes it more readable. For example, some people just have A, B's, and C's as readable names. That won't run in an interview even if you have a software code because no one can understand what it's doing. So it's I would just take a focus on readability, and in an interview, just keep track of time as well so that you don't get like too lost and you spend like 30 minutes in one problem and you don't have time for the second.
Thank you. Thank you. I think we'll just hold up for 1 or 2 minutes and see if there's any question. But okay, I would like to say thank you so much for joining. And I think the problems that we solved, I feel at least these are all important. And I feel like these are the sorts of problems that may break or make an interview at some point in the future. So thank you. And also thank you for solving a lot of doubts that we had as to how do you actually make it big into big tech or things like that. I think a lot of people are passionate about it. I'm really thankful for you. And let's just hold up until 1 more minute. Thanks. So yeah, any final tips that you want to give?
I would just say, like you mentioned, because in college it's 6 months, like you mentioned, right? I would say focus on getting everything done within like let's say 3 months. Okay. And then because you also need time. I don't know if I mean there are two ways, right? On campus and off campus. And in both those ways, I don't know when on campus starts, but despite that, I would say focus on 3.5 months, get your preparation done. And then you don't have to be perfect. Some people just want to be completely perfect before applying. It's not necessary. But again, some people don't study and apply, don't do that as well. Make sure you know 80% of what you're coding. Let's say if you know 80%, right? That's a good rubric to kind of say that, okay, I can code apply now if you know 80%.
Yeah. So I think that and one I think this I have one question finally. AI. What is the field like for AI?
I would say I mean, right now the scope is extremely high because of, let's say, ChatGPT, Gemini, other things. I would say it's really interesting and it's the proper time to get into AI, I would say, because the hype is very high right now. And also, I don't think like jobs will be eaten away so soon, for example, like people are saying, because at the end of the day, people coding AI as well as humans at this point, and despite that, AI is not at a level where it can replace coders. Maybe if it's grunt work, you might like, for example, if it's something that does not require a lot of coding, it might eventually get replaced. But I would just say if you keep up to date with the trends, if you get familiarized with coding and you go ahead, I would say it's kind of chill. But I would say it's really useful to get into the field right now if you're genuinely interested.
Got it. Yeah, so I think that's the time for today. And again, really thankful for you
Thank you very
joining.
much.
And thank you for all of you who came here. And I saw a lot of people asking us doubts, Aaron, Srija, Ashwin. So thanks to all of you for making this such a good stream.